Welcome. Today we're talking about our sixth project in a sixth project series. So this is the last one. And what we're trying to do is solve a maze using MicroPython, a BBC microbit, and a McQueen Plus version 2 robot. So last time in project 5, we used the left-hand rule for getting through the maze. As you may recall, the left-hand rule is we turn to the left, see if there's a wall. If there is, we go next to it, and we get through the maze by basically keeping our left hand on the wall as we try to find the goal. As we were doing that last time, we were making a maze. We were making a map of the maze and where all the walls are, starting out with all the walls around it in place to start with. This time, we're going to use a different maze solving algorithm. And this algorithm is called flood fill. There's more about flood fill in the slideshow that comes with this video. It's down in the comments section. And basically what we're trying to do is for each crossroad, assign it the value of how many crossroads away it is from the goal. So if we're at the goal, the cost is going to be 0 because we're already at the goal and we don't have to go anywhere. Any crossroads which are 1 away from that will have a cost of 1. Any crossroads that are 2 away from that will have a cost of 2. Now, we're going to do that flood fill using the map as we know it. So if there's a wall, then we can't say that this is a 2 because there's a wall. We can't get through there. So there'll be 0, 1, 2, 3, 4, 5, 6, 7. So using flood fill, this has a cost of 7, whereas this has a cost of 0, this has a cost of 1, because to get here, from here to there, it will cost you 7 moves going around. So when we start out in the lower right corner, we don't know where any of this is. So we're going to be very optimistic, and we're going to say if we don't know what's there, we're going to assume that there is no wall there, and we're going to flood fill that way. And that's going to give us this idea of taking the most optimistic path to the goal. As we find walls, we will re-flood fill, and that will then take the walls into account and give us another optimistic sort of estimate of how far away we are. Once we get all of these walls in, though, when we flood fill, we will have an the best optimized path through it. So let's see what we're going to do. So we'll turn this on, and like last time, we're going to push the button to make it go. That's not at all what it's supposed to do. All right, so sometimes, because robots live in the real world, they do things that you don't want them to. Sometimes when you try it a second time, they do what you want them to do. So as you can see, at each point, it's turning around, sometimes completely around, to figure out where the walls are. You'll notice it didn't come here because it didn't need to. That is clearly not an optimal way to go. So as we're going through, we've made a map, we've put all these walls in. Come here, we're going to put some more walls in, this one. Now we know where all the walls are, and we can just go to the goal. Now, like last time, we're going to come back with our robot now has a map. Let's try it again. Now it knows where all the walls are, so when it flood fills, it actually finds the optimum path to get through the maze, right like that. Okay, now, there is a different way to do that. There's a second way to do that. So whereas I call this robot curious, because it's looking for all the walls as soon as it comes to a crossroad that has some unknowns in it, this one is, I'm calling lazy. Now this one, like in the previous project, will only check for a wall when it's pointed in that direction. So when we flood fill, we may not know all of the walls that are around the robot at the time we flood fill. So as we turn to what we believe is the best path, we could do a range finding and see that there's a wall there. At that point, we will have to flood fill again, given what we now know, and try to then pick out the best path. So let's see what happens when we do it that way. Now you'll notice it's not twisting and turning and going in circles, because it's only checking for walls when it believes that is the best way to go. So it doesn't know about this wall, it doesn't know about that wall either. And it finds its way. Now if we try it again, it does not know the complete map. Doesn't know it. So it may have to check for more walls. And there's one right there. It did not know about that wall. So now it's trying to find the optimal path, but there are walls that it didn't know about. Now it already knows about these walls, so it can go right around them. It knows it can go right around them. Now, on a third time, it should know all the walls. So we're expecting it now to actually follow the most optimal path, like to the goal. And that's what it's doing. Okay, so this is based on what's called the micromouse competition. And in the micromouse competition, you were given 10 minutes on a much bigger map to start your robot, run it through the maze, have it collect information about the maze, and hopefully then you can run it and it picks an optimal path and you get your lowest time from start to finish. What we're doing here is basically the same thing. We're running the maze, gaining information so that the last time we run it, it chooses an optimal path. And flood fill is what's generally used in the micromouse competition. You can look for the micromouse competition on Google if you're interested. So that is project 6 in the series. Use the map to eventually come up with an optimal path through the maze. Okay.